Video about MANOVA and ANOVA, and this is the third video. In previous video I discussed part 1 and part 2. Here we'll discuss in further. Let's talk about the special case of MANOVA repeated measures. As we discussed a number of situations in which we wish to examine differences on several dependent measurements. A special situation of type occur when the some respondent provides several measures such as test score over time, and we wish to examine them to see whether any assumption without special treatment, however, we would be violated the most important assumption, independence. Spatial MANOVA model termed repeated measurement model account for this independence and still ascertain whether any differences occurred across individual for the set of dependent variables. The within person perspective is important so that each person is placed on equal footing. For example, assume we were assessing improvement on test score over the semester. We must account for the earlier test score and how they related to later score, and we might expect to see different trend for those with low versus high initial score. Those we must match each respondent score when performing the analysis. The differences we are interested in a become how much each person changed, not necessary. The change is grouping means over the semester. This is a thumb rule of research design of MANOVA. Cell group are formed by the combination of independent variables. For example, a three category non-metric variable, that is low, medium, high, combined with the two category non-metric variable, that is gender or male versus female, will result in a 3 into 2 design with 6 cells group. Sample size per group is critical design use. Minimum sample size per group must be greater than the number of dependent variable. The recommended minimum cell size is 20 observation per cell. Researchers should try to have approximately equal sample size per cell. Covariates and blocking variables are effective ways of controlling for external influence of the depending variable that are not directly represented in the dependent variables. An effective covariance is one of that is highly correlated with the dependent variables but not correlated with the independent variables. The maximum number of covariates in a model should be 0.10 into sample size number of group 1. We do not address the detail of reporting measurement model, that is the become it is a special size from a MANOVA. The interested render is referred to any number of excellent treatment on the subject. Let's talk about the stage 3, that is the assumption of ANOVA and MANOVA. The univariate test procedure of ANOVA described in this chapter are valid. In a, stati- in a, stat- in a stat- statistical sense, if it is assumed that the dependable variable normally distributed, the group are independent in their responses on the dependent variables and variance are equal for all treatments group. Some evidence, however, indicate that F test is ANOVA are robust with regard to these assumptions, except the extreme case. For the multivariate test procedure of MANOVA to be valid, three assumptions must met. Observation must be independent. Variance covariance matrix must be equal for all treatment groups. The set of dependent variable must follow a multivariate normal distribution, that is any linear combination of dependent variable must follow a normal distribution. In additional statistical assumption, the researcher must also consider several issues that influence the possible effect, namely the linearity and multicollinearity of the variate of dependent variable. Independence, the most basic yet most serious violation of it assumptions come from a lack of independence among observation, meaning that the responses in each cell group are not made independently of responses in any group. Violation of this assumption can easily the experimental as well as non-experimental situation. Any number of extraneous and unmeasured effect can be affect the result by creating the dependent between the group. But two of the most common violation of independent follows the time ordered effect serial correlation occurring if the measure are taken over the time even from the different respondent. Gathering information in group setting so that a common experience such as noisy room or confusing set of instruction would case a subset of individual those with the common experiment to have answers that are somewhat correlated, although no test provide an absolute certain or detecting of all form of dependent. The researcher's solution explore all the possible effect and correct form. If found one potential solution, it can combine those within the group and analyze the group average score instead of score of the separate respondents. Another approach is to employ a blocking factor or some form of covariance analysis to account for the dependence. In either case, or when dependence is suspected, the researcher should use a stricter level of significance, that is zero point zero point 0.1 or even lower. Let's talk about the equality of variance covariance matrix. The second assumption of MANOVA is a equivalence of covariance matrix across the group. Here are we are concerned with substantial differences in the amount of variance of the group versus another for the dependent variable. Similar to the problem of heteroscedasticity in multiple regression, in MANOVA with multiple dependent variables, the interest in the variance covariance matrix of the dependent measurement for each group. The variance equivalence test is very strict test instead of equal variance for a single variable in ANOVA. The MANOVA test examines all of the variables, then 5 correlation and 10 covariance, and all tested for equality across the group. As a result, increase in the number of dependent variable and or the number of colors using in the analysis make the test more sensitive to finding differences, and those influence the significance level of used to determine if a violation has occurred. MANOVA program conduct the test for equality of covariance matrix, typically the box-M test, and provide a significance level of test statistical which indicate the likelihood of differences between the group. Those the researcher is looking for non-significant difference between the group and the observed significance level of the test. Statistical is considered acceptable if it is the less significant than the threshold value for comparison. For example, if a zero point zero 0.01 level was considered the threshold level for indicating violation and the assumption value greater than 0.0401, that is 0.02, would be considered acceptable because they indicate no difference between the group, whereas values less than zero point 0.1, for example 0.001, would be problematic because they indicate the significant difference and hence were present. Give the sensitivity of the box M test to size of covariance matrix and the number of group in the analysis. Even simple research design for the 6 group, which a small number of depth variable will went to use to every conservation level of significant differences, that is zero point zero 0.01 rather than zero point zero 0.05, when assessing whether the differences are present. As the design complexity increase, even more conservative level of significance may be considered acceptable. The box M test is especially sensitive to departure for normality. Those ones should always check the univariate normality of the all dependent measurement before the performing this test. Fortunately, a violation of this assumption has minimal impact in the group R of approximately equal size, that is largest group size, smallest group size 1 point, smallest group size lesser than 1.5. If the group size different from then this amount and the significance level of box M test are now within acceptable level, then the researcher has several options. First, apply one of many variants stabilizing transformation available and reset to see whether the problem is remedied. If the unequal variance persist after the transformation and the group size different markedly, the research should mark adjustment for their effects in the interpretation of the significance level of both main and interaction effects. First, one must ascertain which group has the largest variance. This determination is easily made either by examining the variance covariance matrix or by using the determinant of the variance covariance matrix, which is provided by all statistical program by both measuring high values indice greater variance those. If the larger variance are found with the larger group size, the alpha level is overstated, meaning the differences should actually be assessed using the somewhat lower value, that is use 0.3 instead of 0.5. If the larger variance is found in the smaller group size, then the reverse is true. The power of the test has been reduced and the researcher should include the significant level. In most situations, the presence of relatively equal sample size among the group magni- uh, mitigates any variations of this assumption. Thus, it is important to reinforce the importance of analyzing design in maintaining equally sample size among the group. Let's talk about the normality. The last assumption of MANOVA concerned normality of the dependent measurement. In this strict test sense, the assumption is that all the variables are multivariates normal. A multivariate normal distribution assumes that the joint effect of two variables is normal distribution. Even though this assumption underlines most multivariate technique, no direct test is allowable for multivariate normality. Therefore, most researchers test for univariate normality of each variable, although univariate normality does not guarantee multivariate normality. All variables meet this requirement, then any departure from multivariate normality are usually inconsequential. Violation of the assumption have little impact with larger sample size. With larger sample size, just as is found with the ANOVA, violating this assumption primarily created problem in applying the box M test, but transformation can correct these problems in most situation. With the moderate sample size, moderate violation can be accommodated as long as different senses due to skewness and not outlier. Next chapter I will discuss about the linearity and multicollinearity among the dependent variable.